Okay. And then I'm going to share my screen and I'm going to show you a short video of me talking on a whiteboard. Okay. And I'm hoping you'll be able to see this. We'll try it anyway. Okay. So I'm going to share my screen. And then you guys tell me if you can see and hear this. Okay. Can you hear that and see it?
Yeah, it's very, very quiet.
Pretty quiet.
Well, don't make any noise then. Right. I can talk through it, I think. Let's see here. We're going to say no there. And it's 6 minutes. Let's see here. If I turn the sound off, then I can probably tell you what that strange guy is doing. I'll try that. And you tell me if you can. Okay, so I'm explaining here, we're going to talk about flowcharts and decisions, okay? So there's three different types of structural coding, okay, before you even get to object-oriented programming. So I'm writing those on the board. And the first one we're doing already, which is sequential. Tonight we're going to start looking at decision and selection. And that'll leave us repetition and iteration in the future, okay? So this is what I'm going to explain here on the board, I believe. And again, jump in if you don't understand. So like I said, there's three different structures that we do when we do structured programming. What's this guy doing? He's very slow. He's an old guy. So this is, the first one we're talking about is just a plain if statement, okay? It has one result, okay? An else if it has two results. Then we have something called a switch or case structure that can have multiple results. And again, when we're making decisions, the sequential that we were doing before, you have to run every line in order. In selection, we can go one way or the other or not do anything, okay? So now I'm going to flow chart this, I think. Yeah. The first one I'm going to do is an if statement, and it has one result. I've had arguments with book publishers that in reality, there's two possibilities. If you don't either do nothing, which to me is a result, or do something, what they always say there's only one result, and that's the one that you actually do something. So that diamond up there is a decision in flow charting, and then the process is a process, do something, okay? So in there, we have some type of test in that decision. And if the test is true, it goes one way. If it's false, it goes the other way. And that's a straight if, okay, with one result. Well, you guys can't see. I probably don't have any shoes on. I usually teach without shoes, so. In this next one, this is an else if. So we have the one process on the true side, and then we're going to do the false side. Now the false side's also going to have a process, which means if it's false, do something else. So the one side might say winner, the other side says loser. Okay. So that gives us our two results. So that's an else if. And we can nest other ifs in there. Okay, by that I mean we can put an if inside an if inside an if inside an if. Or we can put some sequential code in there. Or we can put repetition. So those three structures you saw before, we can put inside of each other, and it's called nesting. Okay? You guys hearing me?
Yep.
Yes.
So this is a switch, and this is a special kind of decision where we switch depending on the value. We're going to change what is executed. So it gets the information there, and instead of going one way or the other, we can have multiple processes. So let's say, for example, up there in that switch in between the parentheses there, it might say, if it's a 1, do this. If it's a 2, do that. 3, or it might say value. Okay, switch value. And then if the value is 1, it would do the left one, 2, the next one, 3, the next one, 4, the next one, something like that. Or the switch could be somebody's name. And if it's Mary, do the first one. Second one is Doug, do that one, et cetera, et cetera. The problem with a switch in Java is they're not used to do ranges. Okay, it's really hard to do a range. In some other languages, you can say, okay, if it's 1 through 20, do this. If it's 20 through 25, do this. If it's 30 through 40, do this, et cetera, et cetera. You can't do that with Java. So the switch becomes a part that, you know, if you have 3 or 4 numbers that you have in a row, 1, 2, 3, 4, or some values like that, the switch is pretty handy. But as soon as you say, okay, if the age is under 12, do this. The age is 12 or 13 to 20, do this, etc. It becomes really hard to do that. What is this? I don't know what that is. Yikes. I don't want to go to you, buddy. Okay, how to make something, it says. How to make a Lego safe. Okay. So that's what's in this video, and it kind of explains that. Let's look at this one. Why is this up here? Hang on. Okay, just looking at this, okay? In Java, these are our logical operators. So these are the operators that are used after the relational operators. Your relational, okay, so you have your math operations, then you have relational operations, and they're the ones like is greater than, less than, equal to, all that kind, right? Less than and equal to, not equal to. Those are relational operators. And then you have what are called logical operators, okay? And you can see here, enrolled in Computer Science 115 and at ICC, okay, and that kind of thing. So the first one, decision tree, is for not, okay? And it's a pretty simple one. If it's not false, it's true, right? If it's not true, it's false. Okay, the next one's a little different. This is the and. And so I'll say, okay, the first statement I'm going to say is, I go to ICC and up here, I am in computer science 115. So I have a true that I'm at ICC and I'm in computer science 115. So a true and a true is true. The next one is I'm at ICC and I'm in English 110. That's false. So I have a true and a false, so that becomes false. Then I have I'm at Blackhawk College, which is false. And I'm in computer science 115, which is true. So I have a false and a true. That's also false. And then I have I'm at Blackhawk College and I'm in English 110. And in that case, they're both false. Stop. In that case, they're both false. Okay. So what can I generically say about an and operator? Somebody.
If any one option's false, it's false.
Yep. Or you can do it the other way. To be true, they both have to be true, right? And this is the symbol. See these two ampersands? That's the symbol for and in Java. Okay. Move over here and I can say, I go to ICC, that's true. Or I'm in computer science 115. So I have a true, and so I get true. I can say I go to ICC or I'm in English 110. Well, I got a true or a false, and that's also true if you listen to it. I go to ICC or I in English 110. Okay. And I think if you say it, you can understand why it's true. Same thing here. I go to Blackhawk College. Let's see. Yeah, I go to Blackhawk College or I'm in computer science 115. Well, since I'm in computer science 115, the statement is true. I go to Blackhawk College or I'm in English 110. In that case, it's false and false, so I get a false. Okay? So what can I generically say about an or statement? And you'll notice here it's two pipes. And the pipe is right above your enter key, the shift backslash. Shift backslash is the pipe. And generically, somebody else that hasn't answered, tell me what I can generically say about the or statement.
If either of them are true, it's going to be true.
That's it. If either one of those are true, either statement, then it is true. XOR, I'll explain. This one's a little bit different, okay? Let's say that you have a grandmother and your grandmother bakes pies and cakes. And the rules at grandma's house is she doesn't want you to be a pig, okay, or a glutton, whatever you want to call it. So you can either have pie or you can have cake, but you can't have both. And the other rule at grandma's house is you don't want to tell grandma that you don't want pie or cake because then she'll be sad, okay, that you don't think she's a good cook. So here you can see, let's see here. So you got cake. Let's see here. How do I got this set up? Ooh, there's an error. Because in reality, this is an error right here. This one that says, Because if this is cake and this is pie, okay, and this is cake and this is pie, I cannot have cake and pie. So the one right here, if you see where I'm marking, should be false. Okay, I'm going to have to fix that because you can't have both. Now, can I have cake and not have pie? Yes, I can. That's true. Same thing here. I can not have cake, but I can have pie. That's true. But I cannot refuse both cake and pie because grandma will be sad. Okay? So that's how the logical operators work. And the symbol for XOR is a caret, an uppercase 6. And I very seldom have ever used that. So just so you know that. Okay. I think that's the right one. There we go. All right. So kind of get those. Yes, no. Okay. Nobody's talking. Lesson 3. Let's see what we got up. Another one of my rules is that, or not a rule, but it's a good idea not to use not unless you really have to, okay? You really, because it starts getting a little tricky. I mean, for example, if you said gender is not equal to male, how would you rename that and not use the not? Gender is not equal to male. How can I reword that?
Can you just do gender is equal to female?
Yeah. Yeah, just change it to gender is equal to female. Okay. Sometimes you'll have to use it, but it does complicate things really quickly. Okay. I just want you to know that. Okay. All right. I have a mosquito in my room here, and I think it sneaks up on me. They're these little bitty ones this year. They're not like big mosquitoes. They're itty bitty ones. They're aggravating. I gave you this truth table here. I found on YouTube. I think the link works. Uh-oh. Got to get rid of that too. Darn it. Let's see. So, but you'll have one in your, you could always Google it if you don't understand what it is anyway. But now you'll have one in your video anyway because I just told you about it. And it should have been recorded. So let's go ahead and write a program. What do we got here? Rock, paper. This is also, if you don't know, called Rochambeau. So if you like Rochambeau, you can use that instead of rock, paper, scissors. One key that I won't let you do not, you're going to have to generate random numbers like 1, 2, and 3 or 0, 1, 2. Don't leave them. It should say you drew rock. The other used the computer drew scissors. It shouldn't say you're a 1 and it's a 2. That's not the name of the game. You have to have that it's rock, paper, scissors. Okay? Rock, paper, scissors. Random month, that's a pretty easy one. So I think we'll take a look at that one. Okay. In a month, this is probably pretty straightforward. Yeah, we'll knock this one out pretty fast. So I'm going to go to Java, NetBeans. Once again, I use Ant. Do not use Maven, or I forget what the other one is even. So we go here, and then cancel that. File, new project. There we go. And you can see here, don't use Gradle, don't use Maven. You have to use Ant. And I'm going to name this random month. And I'm going to save it on my desk. Somebody asked, well, should I be saving my programs on my desktop? Well, probably not. You want to save them someplace that if that you know where they're at, but that you can recover them if something happens. Okay. And of course, you've got that, the drive out in the cloud, your Google Drive or whatever it is. All right, so I'm going to hit finish. Again, if you have questions that I'm going, I cannot read your minds. I can't see some of your faces. So you need to speak up. Don't be embarrassed. There's a lot of people in this class that have never programmed before. So, don't think that that you're the only one that has questions, because that is not the case. And again, there is a class participation score. So that comes into play as far as asking questions and things like that. So my program is going to be the Acme monthly random month generator or something like that. This is called random month .java. The date today is 8/25/220. And the author is you. And if I'm typing too fast for you to keep up, let me know that also. So now I'm just going to clean this up a little bit, get rid of all the Java docs stuff, line up again, I'm pretty anal about lining up my indentation, my braces and my indentation. So I'm just going to do this. And again, you'll see when these dividers become in handy down the road as we go through the course and we start adding other methods outside of the main. We're going to eventually divide this into inputs, processes, and outputs. Okay. So there's a couple different ways to generate random numbers. Your book's going to show you one way. I'll show you the way I prefer to do it. I'm going to import a Java utility, not a scanner this time, but a random. So just like that. Okay, so this is a library containing code to be able to instantiate a random object. Okay, so that's like the blueprint again, okay? I'm not creating anything at that point, but then I'm going to come down here and create a random. and I'll just say it's a random, and I'll call it RND this time, is equal to random, like that. And, oh, what happened here? Oh, I forgot new. There we go. So now here, I instantiate a random generator object. And it's called what? RND. Okay, so now I want to
I have
go
a
ahead.
question.
Yeah, go ahead.
The parentheses that are right next to each other that are after random, that no matter which like utility it is, that will allow you to enter in whatever value you want when you run it, correct?
I'm going to do it outside of that. You'll see. In some of them, you have to put something in there. It just means that it's, that there has to be something. And I'm going to show you here in the next line, okay? So I'm going to generate, okay, number between 1 and 12. I don't want 0, okay? So I got to keep that in mind. Because if I generate something, normally what random does, it generates a number between whatever you say. Well, let me see. I'll show you. Okay. Let me show you first. Then you'll be able to see it. So I'm going to say my int number, or let's see. Is equal to RND next int. And then if I put 12 here, I think that's right. Sometimes my format's not always good. Okay, so that didn't yell at me, okay. So in this case, if I print this out, if I print this out, so I can test it now. And I get 3 the first time, 11, 10, 0, 2, 2, 6. And I can do this as many times as I want. I will never get a 12. Because what it's saying here is I want to generate a number between, I want to generate 12 digits. And there's 0 through 12. Okay. Well, that's fine. And I could make January 0, February 1. I'd have 12 numbers to generate. But does that really make a lot of sense? If I told you I was born in November and that's month 10, would that confuse you?
Yeah, it would.
It confuses me. Yeah, I don't want to be born in the 10th month. I was born in the 11th month. So what we're going to do here, since I know that generates a number between 1 and 10, what can I do? I mean, 1 and 0 and 11, what can I do?
Just add 1 to it.
There you go. All right. Now, when I run it, there's a 12. And if I show a 0, something's definitely wrong, right? So I'm generating all those randomly. Okay? So this is how I do it. There is a math random one that you can also use. I think they spell it out in your book. But I prefer this one. And again, that's just my preference. That doesn't mean you can't use the one that the book uses, okay? So this generates a number between 1 and 12. So now what I could do here is I can say switch. And what do I want to switch? Well, I want to switch the month number. And then I can go through them. I'm going to run this out. I'll leave it here so that you can see it, but I'm not going to use it anymore. What happened there? I think that's right. Is it not? Or not? I don't think it's a capital. Is it a capital? No, it's not a capital. In this case,
I think you put a colon instead of semicolon, or is it supposed to be?
I got a colon there.
Hmm.
That's what it's supposed to be. There. And why? Oh, because I haven't put anything in there yet, I don't think. Okay, so I'm going to declare a variable up here, and it's going to be a string, and I'm going to call it month. Okay. So inside of here, I'm going to say month is assign the value January. Okay, I got something goofy here. Something wrong with my format. Was it case equals 1? Switch month.
You
Open.
have to put a space between the case and the one.
I didn't have one. I thought I had one. Maybe
And
I
then-
didn't.
Yep.
Oh, there we go. Thank you. I didn't know. And what I have to do here, if you don't do this, you'll always get December, no matter what the number is. Okay. And I prefer this format. I can string these out, but I prefer doing it this way. I like nice little organized. Again, I like my structure so it everything looks good. I use a lot of braces in my structures. And then, so this will be month is equal to February. Again, make sure you spell correctly. And then what I can do here is Control C, copy that, come down here, do that, and then clean it up a little bit. Oh, I forgot my break in there, darn it. Those are lined up. That's lined up. These should be out here. That's lined up. That's lined up. So I get down here, February, so this one will be March. Change that to 4. Then I can go like this. So this one will be 5, 6, 7. Oops, I missed one here.
Professor Peterson, I know what the breaks are by the what I was gonna say from previous programming stuff I've done, but I don't think you ever specifically ran over what the breaks are for.
It stops the program at that point from running down. If I don't put a break here in each one of these, if the case is 1, it'll say, okay, it's January, February, March, April, May, and it'll end up down at the end as being December. So it stops the code from running inside this. You understand, I was inside this is my main. Then inside, then I go down here, I'm in my main. Now I'm inside my switch. Okay, so inside my switch, if I hit a break, I come out of that switch and go down to the next line of code. So that's what it prevents it from doing, or makes it do. If I don't put those in there, whatever the last one is down here would be the one that in fact that's going to print once I get it there. Oops.
So you mean the break just makes sure the switch is applied to each case?
It just stops it. Once it finds the answer, it doesn't go any further. In other
Keeps
words,
it from running each month continuously, or
yeah, no.
oh,
So let's say I generate a 3 here, okay? So it comes in here and it says, is it a 3? Is this a 3? No, so it doesn't do that one. Comes here, is that a 3? Nope, don't do that one. Is this one a 3? Yes, it is. It makes March sign it to month. If I don't have a break here, it keeps going and says, no, April's month. It says, no, May is month. No, June is month. No, July, et cetera, et cetera.
I
But
see.
because I have a break here and I hit 3, it does March, and then boom, it doesn't do any of the other ones. Comprende or not?
Yes.
Yeah.
Once it finds one, we want to stop it. There are instances where you can trick it. By that, I mean, let's say I had something that said, if I wanted to print apple pie, if the number was 1, 2, or 3, I could put case 1, no break, nothing in here. I could put case 2, nothing in here. Then in case 3, I could say dinner is apple pie, or dessert equals apple pie, and do break. And it would skip through 1, it would skip through 2, and then it would hit 3. Okay, so if it generated a 1, a 2, or a 3, I would get apple pie. But that's a little more complicated. Okay, where am I at? June, July. This one should be August, I believe. This one will be October. And I need 2 more. So this one will be 11. This one will be 12. Be November. And this one can be December. And if I had people putting in the data, I would have another case down here. And that case would just say default. Okay. And it might say this, it might say month, or I could have it as so if for some reason my program went berserk and generated any number that isn't in the list, it would print out that error message. Oh, come on. I got a colon there. Okay. So once it's processed, then it comes back out to here, which matches up here. And if you want it indented a little more so you can more specifically see it, you can go ahead and hit that an extra time. Now you can see my indentation is better. Okay. And instead of putting a print in every one, all I'm doing is assigning a value to month. When I'm done and I get back out, let's see where I'm at here, outside the switch, I can now put oh, that was lovely, Doug.
Oops.
I think it's gonna throw an error.
Who's this?
Me, Josh.
Oh.
When you initialize
What did I
months,
call? Oh, it's something
you have
else.
to create an object.
Let's see. Month, no, month.
And
String
string
month.
month equals new string, or just equals
No, you don't.
empty.
Oh, here it's saying I didn't initialize it. So all we're going to do is we're going to come up here and just say initializes as double quotes. 2 double quotes, and that's fine. You can also use this if you want. Same thing as double quotes is string empty, or it should be. Come on. Should be okay. No? Why isn't that working? Well, for now, just use double quotes. I have a mind.
Is
thing
it
going.
because it's outside of the switch?
You don't want it in the switch.
Oh,
If you put this in the switch, it won't be seen outside the switch. So in other words, if I declare this, here, I'll show you. If I take this and control exit and put it in here. Okay. Now it's going to say cannot find it. Doesn't know where it's at. Okay. If I move it back out here, then it can see it. It shouldn't be in there anyway. It doesn't like it in there. Okay, let's see if this thing works. Let's save it. So my random month is July, August, February, October, November, March, and you want December. You want to kind of run through them, make sure you're getting them all. There's a January, I saw it, December, February. So I think I'm getting them all. I saw January and I saw December. So I think I'm pretty good. Okay. So then down here to just clean it up at the end, I'm going to just do a and down here, I'll just run this out. And that would complete that program. Notice I don't even need a scanner on this one because I'm not asking for any input from the user. So I don't even have a scanner.
What bracket ends your switch at the bottom?
This one.
Thank you.
And I can tell because if I click on it and go up here, it matches up there. Now, is anybody having trouble that was following along? Are you having trouble? If you are, we can bring it up and tell you what's wrong with it.
I think I'm still printing or typing things out here.
I just wanted to ask about the random. I know that in some languages you have to import a specific library for random, and it's usually based off the clock time of a computer as its seed. Do we get into how the random works in NetBeans Java?
Right here.
Oh, okay, got it.
And it'll tell you here. I'll show you something. Let me go back here. If I choose random out of this list, let me get there. And you look up here at the top, it tells you what
What it is and what it's for.
it does, how to change it, whatever. Okay.
Got it.
So it explains it there. Yeah, it's a pseudo random number. Based off of the clock.
Are you okay with us using, for example, java.util.asterisk instead of just...
No.
Okay.
His question is, if you want to use all the utilities, you can do this, which is fine in reality. My problem with it is you're learning these and I want you to know them. This one just says use anything in there. Anything in the utility is free game, okay? It doesn't use any more memory than doing them individually, because the only time the memory is affected is when you actually instantiate. So my memory, just by saying that, does nothing to my memory. It's when I do this here, where I actually create the object, that I use up memory. Okay. But the only, and again, it's a valid question, whoever asked it, is that I can use a wild card here, a splat, and get them all. And then I just have to instantiate them down here. But I would prefer in this class, since you're learning them, that you specify which ones you're going to use. So I know you know that that's where they're coming from.
Just out
Okay.
of curiosity, what he just said, if that was okay to do, you'd use that if you were like using a bunch of different utilities.
Yeah. In other words, if you had a bunch of, you had 10 utilities listed up here, I'd probably just throw the asterisk in there.
Otherwise, you'd have to write import Java utility.
Import,
10
import,
different times.
import, import. Yep, exactly.
That's all I had.
Yeah. Another little thing you could do here to clean it up a little bit, you could say final int I'll just make this months. And then I could replace this with a literal. So that cleans it up a little bit more. How's everybody doing? You should have a program now.
Yeah.
Yep.
Should run.
Yep.
And of course, all you're going to do now is go ahead and you can close it out if you want. Boom. Save all, I'm going to say. And I can look over here. Here it is. Don't even open it. I'm not going to even look inside there. I'm going to say send to, compressed. Boom. There it is. And now I move it over into my ePortfolio. And that one's done. So no questions on that one, right?
Nope.
All right.
No, not right now.
Cool. All right. So we got time left. So let's go to take a look here at lesson 4. And let's see here. Let's see. Procedure, decision selection, and the time I describe how to think about it. Oh, okay. Let's watch this one. Hey, no sound at all. Tell me if I turn this up, is that any better?
No,
Maybe if your
it's-
microphone was closer to the speaker of your computer.
That's impossible. I got headphones on.
yeah, it's just going through your mic, not the computer
Oh,
audio.
Yeah. When you share your screen, there's an option to share computer desktop audio.
yeah, I thought there was. Sharing security stuff. it's at.
Here are false here.
How's that?
Yes.
That's working.
Yep.
All right.
And I've got these 3 decisions to make.
Let me back up now.
Deeper look into what's the logic behind it, okay? We talked a little bit about it, but I really would like to do something like this. If I go here,
I must have just got a
and I
hair.
have a decision here, then I have another decision,
Do you guys still hear me
and then I
talking?
have another decision.
Yeah.
Yeah.
Yes.
All right.
No, it's kind
The audio is a bit loud.
Oh, it is?
of a bad decision. Ah,
Uh,
you tell jokes on video. I don't know.
is that better?
That's good.
Yeah.
True here are false here. Coming in from the top. And I've got these 3 decisions to make.
Now these are nested.
And in the final one, I have a process if they pass all these decisions. Something like that, I don't know. It goes down from there, or from here. All right, so this is false, true, false, true. And my question to you today is, if I had where I wanted to find a student with these requirements. First of all, the student needs to be either male or female, so we're going to call that gender. The student has to be in Computer Science 115. So we'll call that the class they're in. And then the last one is, are they a freshman or a sophomore? Okay, and so we'll say, what do we want to call that? Grade, I guess. And my question to you today is, and this is at ICC, we have a student population of about 12,000 students. I can tell you that during any semester, computer science students run about approximately maybe 100, okay? I can tell you out of that 100, there's probably 5 to 10 female students. It tends to be a boys' game or a men's game. And grade-wise, it's probably 70-30 freshman to sophomore, okay? At ICC, we lose quite a few students from the freshman year to the sophomore year, so I'm taking that into consideration. So you could say 60-40, whatever. So my question is, logically here, we're looking for somebody that is a female student that is taking Computer Science 115 that is a sophomore. Okay? So I'll give you a second to think about that. Dun, 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 dun.
Oh,
That
I'm
kind of
so
thing from
funny.
Jeopardy, you know?
Can't believe it.
Anyway, if you said that
Female.
the first thing we should check for is the class, are they in computer science 115, you're correct. Because if you think about it, I said what, there was 15, 12,000, 15,000, whatever students, but only 100 of them are taking this class, okay? So right here, I get rid of 14,000 or whatever, if it's 12,000, 11,000 students, go right down here and out. The only ones going on to be tested more would be those 100 students, okay? if I would have tested for
Do you guys understand that? I want to get rid of them as quick as I can. Okay. So if I test for, let's see, gender first. Let's just say usually there's more women than men. So let's say I had 12,000. Let's say there's 6,000 women, 5,000 guys. I only get rid of 5,000. That means I got 6,000 going on to the second condition that requires more processing versus if I choose the class, I only have 100 more going on. Okay.
That makes sense.
gender, at ICC, there's a few more women than there are men, but it's pretty close. So I would have had, let's say, 7,000 going this way, 7,000 going this way. So now I'd have 7,000 people going to the true side, which would mean I'd have to do more separation here. By doing gender or class first, I got rid of a lot more people. Okay, I should make this, I guess, 13. It don't matter. Let's just stick with 15,000 or 14,100. I guess it would be. I made a boo-boo there, right?
Yeah, it should have been 11,900.
Yeah, 14,100. We got 100 going this way, 14,000 going this way. Doesn't matter. So here, now what are we going to do? Out of those 100, what do we want to get rid of? Are they sophomore or freshmen? That again was like a 60-40 split. Or are they female? Which
Female.
is about a 90-10 split. We would want to go with gender here, right? Because then I've got out of that 100 up here, I've got about 90% going this way and only 10% going this way. And that would lead me down here, would be the sophomore or the class. Sophomore, freshman, we really don't care. My sophomores would go off to this side. Say there's 5 of them go this way and 5 go down the chute here. And so I would process a total of 5 students. Okay? Checking my time here.
7 minutes almost.
Okay, so I'm gonna leave it at that. Again, sorry about this should be like 14,000 or whatever, and that's the 14.
No, it should be
14,100.
11,009.
But other than that, that's something you have to think about. When you're doing something that has multiple conditions, which one gets rid of the most people or the most things faster? Because then the processes down here become less. We don't want to be running the opposite of this. If we ran it, it would be a lot slower, right? We want to get rid of the most we can, the fastest we can. Okay, I'll be back later with another program for you to look at.
You guys are excited, I'll bet. So, again, so that's kind of that scenario there. What's this one? It says whether a student should or should not receive financial aid. I'll just look at it real quick and see what. Come on.
Hi, I'm back again. In this case, I wanted you to look at some logical operators.
This one's only
when
4
we combine
minutes.
two relational operations. So what I got here is I've initialized a variable called gender of the type char with the letter F for female, a Boolean veteran variable that's set to false, that should be a small f, and an integer age variable which is set at 22. So my question to you, looking at this, it says if age is less than 28 and the gender is equal to female, or a veteran is equal to true, then you qualify for whatever it is. If not, then you don't qualify.
Okay, so take a look at that, and are they going to get financial aid or are they not going to get financial aid?
Well, they would because they're still a veteran.
Well, explain to me why.
Because, well, if they are of age 28 and they're a female gender,
Okay. So that's, what does that assess? So the age is under 28. Is that true or false?
It could also
oh,
be
I'm sorry, I couldn't see that.
Hang on. Is that true or false? Is age less than or equal to 28?
It's true.
It's true.
True.
Okay. So I've got a true, and is their gender female?
Yeah.
Yes.
So that's true. And if we go back to our truth table and we have a true and a true, what does that assess out to?
True.
True.
True, right? Okay. Then we go on. And so now we've got a true, and we have, are they a veteran?
Oh, false.
Yeah.
Okay. But it's, I have a true or a false. So if I have a true or false, what is the answer?
You qualify.
They qualify. Yes, she does. Okay. She qualifies under this side over here, not over here, but it's an or. If this was an and, would she
And
qualify?
they wouldn't. No.
Then
No.
that's right. You're definitely right. She would not qualify if this was an and instead of an or. Okay. So let's hear what else this guy has to say about this.
So now, giving you a couple seconds, which one do you think this person, this female that's not a veteran and is 22 years old, does she qualify for, let's say, financial aid? And the answer is, who knows? Well, let's assess it. Is age, okay, so age is 22 less than 28. 22 is less than 28. So this becomes true. And then we have an and here, and the gender is equal to female, right? So we got, she is a female, so she has a false or a true there. And then over here, so we can take these two together, and we've got a true and a true, which assesses out to true. And then we come over here, and we have, is she a veteran? Well, she's not, so false does not equal to true. So we have a false here. So now I have a true or false. And if you remember, true or false would come out to true. So in fact, our person that is applying here to qualify would qualify for getting financial aid. Okay? If I change this up a little bit, we'll try it again. And let's go ahead and make this a 30-year-old veteran. And with the gender of male this time. Okay.
So on this one, let's take a look at it. Is this person going to get financial aid?
I would say true because they're still a veteran, even though they're older and they're a male.
So this one's almost, you're right, this one's almost the exact opposite, where in the first one, this part was true and this was false. Now on this one, this part here, he's over 30, so that's false, and he's not a female, so that's false. So he has a false and a false, so that goes out as false. And this one over here is true, so I have false or true here. So once again, this person, let's see if I'm right.
So we can see here, is the age less than or equal to 28? Well, no, it isn't. He's 30. And is the gender female? No, he's a male, so that's also false. So we have a false and a false. So if we combine those together, we get a false. Then we have an or, and he is a veteran though, so true is equal to true is true, so I have a false or a true. And again, if you remember from my truth tables, a false or a true comes out as a true, so he would also qualify for the financial aid. So make sure you kind of understand this. Make sure, I know these look like C clefs instead of ampersands, but that's what they represent here. Okay, so this is a little bit.
All right. So you kind of get the idea there. Those are the kinds of things you're going to deal with. Okay. Here's another explanation of what I was talking about earlier. These are your the three different types of structured programming. And later on, we're going to, in the semester, we'll deal with object-oriented programming. Okay. It talks about Park here. Just a short deal on that. When Steve Jobs, when Apple first was founded, and they had started making Apple computers down in Palo Alto, or not Palo Alto, I forget, I can't pronounce the word anyway. But anyway, they were making computers out of his mom's garage at the time. And he'd become a millionaire in that. So he's out riding in his car one day, and he goes by this building called, and on the side of it, it had said Xerox Park. So he stops in to see what's going on, knocks on the door, whatever. And a redheaded woman answers the door, and he goes, "Hi, I'm Steve Jobs. I'd like to know what you guys do here." And so he gets to go inside. Now, something you should know about Xerox Park is at any given time, I think the maximum amount of people that worked there might have been 25, but yet the rumors were that the 30 greatest programmers in the world, or computer development people at the time, worked at Xerox Park. In other words, some of them had more than one brain. So Jobs goes in there and he sees three basic things. He sees that they're running an Ethernet at that time. Back then, nobody ran Ethernets. We had token rings, okay, for our networking. Another thing he saw was object-oriented programming. They were writing programs based on creating objects. And that's what Java is, an object-oriented programming language, okay? And the third thing he saw was they had a desktop and they were using mice and icons. And that was nobody had that technology. So he left, went back to Apple, and told his guys about seeing the desktop. Forgot about the Ethernet, forgot about object-oriented programming. But he saw them using mice and stuff and clicking on stuff. And he went to Wozniak and told him, you know, for every one of us nerds that wants a computer, there are millions of other people that if they could just click on stuff, they would want a computer. Okay. So he wants to take his engineers back over there to take a look. And so he calls up and talks to the redheaded woman. I forget her name right now. But, and she says, no, definitely not. I know what you're going to do. You're going to come over here, steal our technology. And, you know, and so not to be outdone, Jobs calls the IBM headquarters in New York. Now, again, the Xerox headquarters in New York, they didn't even know where Park was and that they even owned the laboratory. Because Xerox was all about copiers. They didn't care about desktop computing or anything like that. And so he got permission over her head to take his people over to Xerox Park. And shortly thereafter, the Mac was born. So he really stole that. Xerox could have owned the desktop industry. They could have been the Apple or Microsoft of today. What's kind of funny though, so he develops, so they start developing the Mac, but he doesn't, they're a hardware company. They don't write software. So who do you think he went to get software for the Mac?
Windows.
Well, it's not called Windows. What's it called? It's called Microsoft, right?
Microsoft, yeah.
So he goes to his old buddy up there, Bill Gates, and says, hey, Bill, I'm going to develop this computer and we're going to click on and stuff like that, but I need some software for it. And Bill, being the Bill he is, says, well, I need to know how it works and, you know, all that kind of stuff so I can write the right programs. So all of a sudden, guess what? What comes out next?
Microsoft.
Windows. All of a sudden, Microsoft, it developed some programs for the Mac, but they also developed their own operating system called Windows. Up until this point, they just had DOS, okay, command line. So now they have a point and click thing with icons that looks an awful like the Macintosh does. And so there's a big lawsuit. Apple sues Microsoft, but guess what? Anybody know, some of you guys, anybody know what case law is? You ever watch a thing on TV where, go ahead.
Could you repeat?
Yeah, I think we lost your connection for
Yeah,
a little
we
bit.
lost-
I'm sorry.
We lost
Do you
your
know-
audio.
Okay, do you guys know what case law is?
No, I don't.
Okay, case law is, have you ever watched TV and it's a trial and the attorney will go, well, according to Smith in 1953, section 4, the case in that instance, they ruled in favor of the defendant. You ever heard that?
Yeah, they just refer back to an old case.
They refer back to other cases that have already been decided. That's called case law. Well, guess what? These operating systems, nobody knew anything about. So there was no case law. Okay? So when Apple sued Microsoft, they could not, the courts just hung and hung and hung for years, okay? Eventually, Apple won, but by that time, Microsoft had sold millions of copies of Windows. And so what they ended up having to pay Apple was minuscule, okay? Minuscule. All right. I'm going to help you out here. I'll start with a little bit here. On the lottery one, just be careful. There's an example of the lottery in there, but it's only for 2 digits. You're going to generate 3 digits. Okay. So, and this is how I want it. I think this is the one anyway that lets you win or lose big money. Okay. So if you match all 3 numbers, the user matches all 3 numbers in order, okay, they win $10,000, let's say. If they match the 3 numbers in any order, okay, any order at all, they just have the same 3 numbers, they win $3,000. If they match 1 number out of the 3, they get $1,000. But they don't, let's say they match 2 numbers, they still only get 1,000. They have to have matched 3 to win 3,000. Or if they match them in the right order, they get 10,000. Okay, that's on that one. On the second assignment, okay, the rectangle I want is let's make it 10 by 5 or 5. I think it's, let's see, what is it? 5 by, it's either 5 by 10 or 10 by 5. Okay. And the rectangle has a 0 on the matrix, on a grid. The center of the rectangle is at 0, 0. Okay. So let's say that the longitude or the x-axis is the 5. So I'll have 2.5 units that are negative and 2.5 units that are positive. Okay. Likewise, on the vertical plane or the y, I'll have 5 numbers that are positive, 1 through 5 or 0 through 5 positive, and 0 through 5 negative. Okay, that means my rectangle's sitting right in the middle with the point, the main point right in the center. So now what the user has to do is put in the X and Y coordinate, and your program needs to determine whether or not that point is inside the rectangle. Okay, so if I have a 5 by 10 and the X is 5 and the Y is 10, is that inside the triangle or rectangle?
No.
Yes, it is. Anything on the border is also inside. So a -5 and a -10, would that be inside? Oh, come on, you got a 50-50 chance.
No.
Yes, it would. -5 would be out there, and -10 or negative, let's see, -5. Oh, I'm sorry. You're right. It's outside. Because I only have, if it's 5, I only have 2.5 in one direction, 2.5 in the other on the x-axis, and 5 and 5. So 10 would be out there. Okay, so would 5 be out there. So it would be not be in. So a -2.5 and a +5, would that be in?
Yes.
That one would be, yes. Okay, that one would be. All right, so you kind of get the idea. Don't be intimidated by that one. The one I'm going to help you maybe with here is let's draw a card, any card. Okay, I'll get it started for you. We might not get all the way done. So I'm going to go ahead and open up a new project. I'll close this one eventually here. Hang on, let me do this first. Let's close this one. Now close that too, Doug. New project, and it's Ant, and then we'll just call it a random card. Again, so this is what it looks like. Go up here real quick. Project, Acme, random card generator. And this will be random card.java. Date will be 8/25/2020. And then author is myself. In your case, it's you. Purpose. Jeez. Okay. So that's what it's going to do. Again, I'm going to use the random generator that's in the Java library. So I'm going to import it. Oh, come on. Locked up. Okay, yeah. I didn't want that. And to clean this up real quick. So it looks like that. There you go. So now I need to instantiate my random generator.
Did you mean to delete the public in front of a public static void?
No.
Okay.
No, I didn't. Sorry. Thank you for catching that. All right. So, let's go ahead and we'll do int suit num will be equal to rnd dot next int, and I'll call that if I just put a 4 in there, I could do that. Okay, so that's my suits, and then I'll put int card num is equal to random dot next int, and that's 13. But in that one, I'm going to add 1 to it because I want ace through king, and I don't have a 0 card, okay?
So wouldn't we only want 3 for the suit since it's 0, 1, 2, 3?
That's 4 numbers, buddy. This
Oh,
will
I
never.
see.
This
Yeah,
will
that's right.
never. This will never generate the number 4.
Okay, that you got to think that -1 is what you're gonna
Yep.
the top
You're
number.
gonna
Okay.
you're gonna get 4 numbers.
But one of them is
Okay.
0.
That's right.
Okay.
Okay.
Question, with like when you put int and then suit number or card number or whatever, how come you don't have to capitalize the I there, but then when you do the next int, you have to?
Because that's how the function. This random has a function, and that's how it's spelled. This is a function inside an object called random. So it's, see how I have the N done here? It's uppercase. That's why. Because that's how we read them, like that. Okay.
Okay.
In this case, if I make it a small letter I, it's not going to work because it's not spelled like that in the library. Okay, does that help?
Yeah, that makes sense.
All right. These, I'm just naming them that. Okay. So now I got my, here, I got my inputs. Okay. So I could actually break this down into input. And in this time, I'm not getting input from a user, so I don't need a scanner. And so now I need to process these numbers that I generated. And you could check. In other words, if I wanted to here, I could go here just to make sure. and make sure I'm getting my two numbers here. Before I move on, because if I'm not getting the two numbers I need, there's no reason to go on, right? All right, let's see what that looks like. And you can see here, I'm getting, that one was 0 and 13, 1 and 7, 0 and 1, 3 and 6, 1 and 10. So it looks like it's working. 2 and 9, 3 and 6. Okay. So I think we're good up to that point. So again, this is just testing that. So you can test, that's kind of like a test there. Geez, this new computer I got, the keyboard. All right, got that. Okay.
I didn't
So-
see what button did you do to like make a line, just a regular statement?
This line right here. I don't know what you mean.
Like, how did you switch it from being like executable to just a regular statement?
Oh, the double slashes there.
Okay, thanks.
Why am I getting an error? Oh, I still gotta. And you can do it like this. Watch this. It's as easy as this. If I wanted to rem all this out, I come up here, boom. Now it's not gonna run anything. Come back. Whoops. Where did I, here. So you got two ways you can do remarks. Slash, splash, slash, splat, and then splat, slash. You get a block of remarks. Or you can do the two slashes and make a remark. Anything that has this or that's grayed out, the processor does not run. Okay. The interpreter doesn't work on it.
I have a question about the integer suite num.
Okay.
If we want to, that's for the four types of suites, right?
Suits,
Wouldn't
yeah.
we choose 3, or maybe I missed it? Maybe you said it,
Well,
but isn't
if
the
you
random
choose
like
3, you're only going to get 0, 1, 2. You only get 3 numbers.
okay? So it's
This
not
is-
0 to 3. Okay.
This here just means you're going to get 4 numbers. 0, 1, 2, 3. This one, you're going to get 0 through 12.
Nope. Got it. Thank you.
Okay. And later on, when we do loops, that even becomes a little tricky, and we'll talk about it when we get there. So now I'm going to go ahead and do a switch, and I'm going to do that for suite num or suit num, whatever you want to call it. And then enter, and then my braces, and then case 0. And I could even put it up above it, but I won't. So I go here, and I need a variable for a string. So I'm going to put that right here, and I'm going to just say string suit is equal to an empty like that. And so in this case here, case 0, my suit is going to be equal to spades. Or even better yet, we'll make it of spades. with a space in front of. And then I'm going to put break here. Next one. Well, this is going to be case number 2. This will be clubs. 0, 1, 2, and this one will be case 3. Or I could just make it the default if I wanted to, but for right now, I'll just make it 3. I know that that's all that's going to be generated because I created the generator. Okay. So now we can see, in fact, if that works. Let's see if it works. So we can say system.out print line and then suit.
I have a question.
Hang on a second. I want to just see if this works. So that printed out of spades because it has a 0 here, right? Run it again. Of spades again. This one's hearts. This one's clubs. Hearts. There's a diamond, okay? So I know I'm getting all 4 suites or suits. What was the question?
My switch line has the red line under it, says reached end of file while parsing. I don't know what I did wrong.
I don't know.
Check your brackets then.
Yeah. My guess is, do you have a brace there?
Yeah.
Okay. Do you have a brace up here?
Oh, that's no problem. Got it. Thanks.
Okay, so now that works. So this is just another test here. So I can get rid of that or just label it as a test. Oops. Okay, but I don't need it anymore. So I could get rid of it. So now I'm going to do the 13 numbers. And that would be a pain in the butt using this. And I'll show you why. Okay, so I'm going to say if the, what did I call it? Suit number or card number? Yeah. Card number is equal to, make sure you double equals 13. Okay. And in this case, I need another variable. So up here, I'm going to say I want string card. It's equal to that. So I got 2 string variables there. So if it's 13, then I want it to the card to be equal to a king. else if the card number is equal to 12, I want it to be card will be equal to queen. And else if card number is equal to 11, card will be equal to, oops, no, or is assigned a jack. And I'm going to go up above king and add another line of code here. Right underneath this, or right above, we're going to change the king to an else if. And then right here, I'm going to put the ace if card num is equal to 1. So fix it so it looks like that. So it should look like that. And finally down here, so you keep going until you get them all, right? No. Oh, watch the next one. So this is, if it's something else, I want the card equal to card number. Oh, it's not going to let me do that, is it? Incompatible types. So now I need, so let's say you're here and you know you want to do that. And let's go over here. No. And I'm going to say Java convert an int to a string. And so here it says integer to string. You can do it that way. Convert an integer to a string. There's all kinds of them. But it will let us do integer to string and then whatever the integer is. Okay. You can do this one. Convert string value of the integer. You can do convert using integer into string. Okay. So there's like 4 different ways to do it right there. I'm going to go ahead and just do using string value of. Let's see if that'll work in our program. And then this will just be, whoops, I forget what it was now. Short-term memory loss. String value of, yeah, okay. So it's string, has to be capital. Okay, so now I can come down here. We're almost out of time. And I can, now I'm outside of my else ifs. I can say system dot out dot print line and then your card is and I run it. Your card is the 10 of spades. Your card is the 5 of hearts. Your card is the 5 of spades. Your card is the Queen of hearts. So that seems to work. And our time, huh?
I have a question about the else if statements.
Okay.
Why did you use an else at the end there when you put the card
Because
equals
this
string
is
of value?
everybody else. I did ace, king, queen, jack. This is 10 through 2 are all serviced by any other number.
Okay.
So I don't have to, here, because some people that were, if they're learning how to program, might have kept going and said, okay, the next one is elf is card number equals 10. Card is equal to, I could do that if I wanted to type out the word 10. But I'm perfectly happy with it saying like this, the 7 of hearts. I'm not spelling out the word 7. Okay. If I wanted to print out the word 7, you're right. I would have to keep going like I was doing all along here. Okay. And then we could clean this up. Just put in no code follows. And you might want to put your little goofy thing in here that says, and there you go. Save it. Run it. And there you go. Your card is the 4 of diamonds. And you could have a banner over that too if you wanted to. We could have gone up here before we printed anything else. And actually right above this, we could have put a banner, card generator or something to that effect. Okay, you guys happy? I did 2 out of the 6 programs for you. Okay.
Thank you.
Thank you.
I'm going to stop the recording